Right. Picture this. You walk into the office on a Monday morning, grab your coffee, and sit down at your desk. But every single server is offline. Every database? Gone. Every core service is completely dark. We're not talking about a temporary glitch here. We're talking about a total, devastating wipe. Today, in this explainer, we're actually going to track a simulated 48-hour catastrophic infrastructure wipe at a real business, Clearview Accountants, which is a 60-person practice up in Manchester. We're going to follow their IT manager through the exhaustion, the unexpected traps, and literally watch the clock tick down to see if they can actually survive.
And look, before we get into the timeline, we have to start with a massive reframe. Most businesses have a disaster recovery plan, right? It's usually sitting in some dusty binder or a forgotten shared drive. But the gap between a paper plan and a real-world high-pressure test, well, that gap is where businesses literally live or die. Because if you've never actually pulled the plug when the pressure is on, you honestly don't know if your plan works. This whole simulation asks one incredibly simple but terrifying question. If the absolute worst happens, can we actually recover?
So let's look at the contrast. A normal Tuesday at 9 a.m., it hums with life. You've got green status indicators, active logins, live data feeds flowing. But hour zero? Hour zero is a massive, shocking digital blackout. Red flat lines, complete network silence, absolutely nothing boots up. Clearview's IT team literally pulled the plug at exactly 9 a.m. And within 8 minutes, just 8 minutes, panic set in across the entire firm as staff realized the internet was totally down and every single client file was locked.
And just like that, the clock starts. Welcome to the zero state. And trust me, it is far more terrifying than anyone ever predicts. Because think about it. Your first instinct in a crisis is always to reach for your communication tools, right? You want to check your monitoring dashboards. But what happens when the dashboard itself is gone? The team immediately slammed into the sheer chaos of a true catastrophe. They couldn't even coordinate a basic response because the very tools they relied on to communicate were hosted on the exact servers that just died. The immediate isolation they felt was just staggering. The internal messaging platform? Completely offline. That carefully written incident response checklist? Totally inaccessible. Even the escalation contact list was erased right alongside the CRM. The only thing that actually worked for Clearview was a personal WhatsApp group that the IT manager had casually set up just a week prior. And that total accident? That became their entire communication infrastructure for the next 6 grueling hours. As we cross into the first 8 hours of the simulation, the exhausted team hits a massive, massive wall. We call it the cold start paradox. Essentially, it's when the critical information you absolutely need to begin your recovery is locked inside the exact systems you are trying to recover. Now, it sounds obvious, right? But almost every organization falls into this trap, because storing your admin credentials in your digital environment is incredibly convenient, right up until that environment completely vaporizes.
They fell right into this inescapable trap, and it's almost comical how frustrating it is. Step 1, they needed the recovery runbook. Okay, step 2, the runbook was in a cloud platform that required a login. Step 3, that login needed the identity server. And step 4, the identity server was part of the downed infrastructure. It's a perfect, dead circle. Clearview's skeleton crew actually spent 2 hours and 17 minutes trapped in this exact agonizing loop.
So how did they finally break the loop? Honestly, pure dumb luck. 6 months prior, the IT manager had just randomly emailed a set of admin credentials to his personal Gmail account. But the actual proper fix for this? It is incredibly cheap. It's an offline solution. Literally a physical laminated emergency recovery card with server boot orders, admin credentials, and emergency numbers. You keep one in a desk drawer, you put one in a safe. That's it. A single piece of A4 paper breaks the cold start paradox entirely. All right, so moving into hours 8 through 24. The exhaustion is really setting in now, and we hit the second nightmare, configuration drift. Here's what happens. You might take a perfectly clean backup at month 1. But over the next 18 months, reality just drifts. Live apps get patched. Developers manually tweak environment variables to fix bugs, and they never actually document it. So your backup is totally genuine, but the live environment it needs to restore into has fundamentally mutated.
And this drift carries a brutal real-world cost. In Clearview's case, a core database was upgraded 3 months after their backup was taken. So restoring the older version meant the applications just flat out refused to talk to each other. Clearview's managed service provider engineer had to spend 4 grueling, agonizing hours manually identifying and reapplying all those missing settings.
That single delay, it cost the business £1,200 in emergency out-of-hours IT rates. Now, those 4 hours of expensive archaeological reconstruction, they could have been entirely avoided with a remarkably simple fix. We're talking about a mandatory one-line changelog for every single production change. If someone tweaks a setting, or if they apply a patch, they just write it down in a basic shared log. 15 seconds of documentation literally saves hours of panic and thousands of pounds during a full-blown crisis.
Hitting the 24-hour mark, operating on drastically reduced sleep, the team uncovers an incredibly cruel variant of our earlier paradox. Let's call this the authentication death loop. They needed to access the backup vault to actually restore the data. But to get in, they were prompted for a multi-factor authentication code. The problem? The server generating those MFA codes was self-hosted inside the down infrastructure. They were completely locked out of the vault because the key was locked inside the vault with it. This brings the entire restoration process to a grinding, horrifying halt. So what's the actionable takeaway here? Your identity infrastructure must have an emergency hardware bypass procedure. It absolutely cannot depend on the systems you are trying to revive. If you self-host your MFA, you need a documented, completely offline break glass protocol for when the house is on fire. No exceptions.
At hour 28, the emotional peak of the whole simulation hits. The IT manager finally has to pick up the phone and confess the delays to a senior partner at the firm. And this is where abstract technical issues slam right into harsh business reality. Because the senior partner, they don't care about authentication loops, they don't care about configuration drift, they ask one devastating question: what is this costing us per hour?
And the IT manager had done the math. £750 per hour. For a 60-person accounting firm with a daily fee income of around £18,000, every single hour they are offline represents £750 in direct, lost billing capacity. This is a sobering anchor. It makes the stakes incredibly real for any business owner. And by the way, this doesn't even factor in regulatory exposure or reputational damage. This is just the raw, bleeding cost of 60 highly paid staff sitting entirely idle.
Adding insult to injury, just as progress finally seemed close, the customer-facing portal just refused to load. The culprit? Shadow IT. Shadow IT is basically an undocumented system that your core applications secretly depend on. Turns out, a previous developer had built a small, hidden database connection 3 whole years ago. Finding this hidden system and then locating an unofficial backup for it took the exhausted team an agonizing 6 extra hours, which equates to another £4,500 in lost income.
Listen, the things you don't document will absolutely hunt you down in a crisis. The only solution here is a ruthless, full infrastructure audit. You need to actively track down every single shadow application. No matter how incredibly small it seems, drag it out into the light, back it up properly, and put it directly into your official disaster recovery plan. Okay, so by hour 36, relief finally begins to set in. 65% of the infrastructure is back online. Email is working again, the core accounting systems are up, but that remaining 35%? It is a grueling final stretch. It requires pulling terabytes of client records out of cold storage and meticulously validating the data. Every single file must be checked for corruption before the business can truly trust its own systems again. That final data validation ate up hours, but finally, full restoration was officially declared. The clock stopped at exactly 47 hours and 43 minutes. The team survived the 48-hour challenge, yes, but they were left with just 17 razor-thin minutes to spare. Literally 17 minutes between surviving a catastrophic incident and total business failure.
Clearview survived, but more importantly, they walked away with a vital 5-fix summary card. This is a crisp, actionable postmortem that you can implement in your own business this week. Docs locked on dead servers? Print an offline pack. Trapped in an MFA death loop? Create an offline hardware bypass. Configuration drift? Mandate a live changelog. Shadow IT? Run a ruthless audit. And the absolute biggest finding of all, an untested plan is a very dangerous illusion.
Which leads me to a final provocative thought to leave you with. A disaster recovery plan that has never actually been tested is just a hypothesis. The businesses that actually survive disasters aren't the ones with the fanciest, most expensive technology. They are the ones who do the unglamorous work, the ones who test their assumptions, simulate the total wipe, and close those painful gaps before the clock ever starts ticking. So if you tested your assumptions, take these 5 fixes and make sure you do, before you find out the hard way. Thanks for joining me on this explainer.